Today, the unknown hero of the internet, DNS.
But what is DNS? Because most people don't see it for what it is.
DNS, whether you know it or not, you use it all the time. When you go to your www dot, the piece you can remember, your domain name system is what goes back and says, hey, this is actually a 192.168. This is a 152 dot something. This is
the
something.
phone book of the internet. This is the replacement of the old way of doing things where they used to enter every single address and name into a host file.txt.
Getting rid of your host file.
Super cumbersome if you look at where we are today. I'd hate to be the guy updating those files.
If we're talking back in 1983 when this was created, there wasn't a whole bunch of stuff. I mean, it was very simplified where you were going, what you were doing.
Yeah, it was the beginning of really network communication across the world where they were trying to find a way of, hey, if we don't keep a record of all these IP addresses, how do we actually distribute this out? At which point in time, they moved from that centralized system of the host.txt to the DNS system we know and use every day.
A lot easier to maintain because now instead of everybody taking their host file, their TXT files, and every time something new comes online, you have to add your TXT file, you have to edit yours, and you forget to add one to yours. Now it's all messed up and conjumbled. Who knows what's going on? Centralized. DNS now manages it all.
The traffic traverses over 13 virtual clusters.
Yes.
Across the world, using hundreds of servers in over 130 different countries to give you basically a glorified phone book. I mean, let's call it what it is.
It simplifies it as, yep, you have 13 main servers that have to be updated. Those 13 main servers, now every time somebody puts in a new application for a new IP address, a new website they want to bring online, the DNS servers now update those and they hold them.
Yeah, and those clusters form the master list that propagates that data down to basically any of your internal DNS. So if you run your own DNS at home or you rely on Google, they're all basically feeding from these 13 across the world.
Yep.
In millisecond response time, because of the way this system is built, right? So as you're sitting at home, when you query, say, yahoo.com, it goes out and it goes to your browser cache. If you've ever been there before, it's going to look there, and it relies on time to live. So time to live being a part of the DNS query that says how long will it stick around.
To better explain the time to live so people can understand this, time to live, it's on your browser. It's going to stay there for roughly 15 minutes to 24 hours, depending on how much you go there, how often you've been there, if it sees it, if it knows you're going to repeat it or not. It's going to keep it locally cached for up to a day.
Yep, and if it doesn't find it in your browser cache, it then steps to your OS cache. Because your OS at a basic level is still communicating between servers, whether it be for Windows updates, whether you're sitting in a business environment talking to the various servers. So then it goes to that cache. If it doesn't find it there, it then steps up to the router level.
Yes. At the router, now we're going out to those bigger servers who cache it for a few more days, a couple of days, two days, 3 days max. And they're going to go out and say, hey, has anybody seen anybody go to this website, or has this website moved? Now it's going into the record list saying, oh yeah, you want to go to Yahoo? Someone else has already been there. I can send you right there. Or, hey, nobody's been to the Yahoo in a day or two. Strange. Or they moved. They switched their servers. They switched their IP. They are now located somewhere else. Go here. They know where they're located at. And they'll start bouncing between those different switches to build your new DNS route.
Yep. So then if it doesn't find it on those levels, it then steps up to the top level domains, right? And the top level domains, they more or less know where to find it, right? They're not necessarily going to respond. They're going to send you on to the authoritative servers, which are going to then respond with the IP address, which is then going to come back to your browser, and that fancy name you typed in becomes the web address, and it directs you over to it. That's the gist of how it works, right?
I'd say most of the time, unless you're a brand new website, you're not going to go back to those 13 global servers. Those are, unless something's brand new, that's, I mean, still, though, to go all the way up and all the way back down, milliseconds. So you'll probably never know if it has to actually go all the way out and find it. But
now, some quick facts about DNS. One, originally created as an unencrypted standard. You still see the unencrypted standard utilized in many places today. Bad parts of that, of course, is it's subject to cache poisoning. It's subject to spoofing. It's subject to interception by things. You'll see it intercepted. Everybody's seen it in a hotel, right? You go to a hotel, you get the guest portal. Well, they're intercepting DNS to direct you to their guest portal temporarily. get you to sign in or get you to pay, and then it moves on.
Before the HTTPSs of the world.
Yeah, and we'll talk on that as we talk future of DNS of where that heads. Other pieces, DNS uses port 53 for those guys that want the fun networking facts. Primarily uses the UDP standard, which most network traffic you typically see moving between servers actually uses TCP because it can reorder packets. UDP is used for DNS because of its fast speed.
That's where you're going for, is the faster speeds, the less encryption. You're not going the TCP encrypted route quite yet. You get a larger response out of your TCP than you will out of your UDP. Yep. But at the end, you want the speed first.
You're less disrupted when you're going TCP because you get that reordering. Now, DNS uses load balancing, and that's really seen as it communicates out to those servers, and it's trying to find where it can go. With that 13 primary virtual clusters of servers, made up of hundreds, it says which one's closest to you, which one doesn't have a load on it at the time, and is going to be able to respond in the fastest. And that's how they achieve that millisecond response time.
And with that, the first thing they're going to do is they're going to go out and look for the records. They want to see what type of records. We're looking for an A record. We're looking for a C record. We're looking for your MX for your mails. We're looking for NX records for filing systems. Yep. They want to know what type of record we're looking for.
So there are about 50 plus standardized. Now, they're not limited to the 50, but there's about 5 to 10 that are more common. You got your A pointer records, which are used for IPv4 addressing. You got your quadruple A records, which are used for your IPv6. Your C names used for aliasing. MX, if anybody actually does email servers or exchange, your MX records are your mail server records. The TXT records, which is probably the most common if you're trying to acquire a domain or prove that you own it, it's used your verification. Or your DKIM or your SPF records, which are now used for basically verification and security sign-off as you talk mail between different servers, so that you can prove that the mail came from that server as well.
A couple other things we forgot to kind of mention at the beginning is when you go to your big DNS, when you go to your 13 mains, the one big thing it's going to look for is your .coms, .orgs, .nets, .govs, and it's going to help split you out from there. Yeah. That's one thing that the main DNS is going to do.
Yeah, basically it's giving us
your
a roadmap to figure out where it is.
Which then will break you down into all the different letters we just gave you of your NS, SOAs, and stuff like that.
Yeah. So what are some issues, though, that we can run across with DNS? I mean, the biggest one?
Split DNS.
Exactly. Split DNS and dealing with propagation of DNS data. So anytime a person wants to update an address and point it to a new server, they go and they make their changes on DNS, whether they're using GoDaddy, whether they're using a private server, host server, whatever. Yep. They go and they make that change. Well, because DNS is hosted across, we're going to say thousands, if not more, endpoints across the world.
More for sure.
That data has to propagate down. And it propagates down even down to that router level of users who are using it. But it takes days, right? So, some, like the local, you'll be like, hey, by the way, I can get to it. Why can't you? And that's a common piece that we see in the networking world of IT is, well, yes, your local DNS has now updated, but somebody across the same city may not have used it. They might be using AT&T towers who are communicating on their routers to a whole different name server at the time.
Which brings us to that time to live, the TTL. Time to live, the older desk. Sometimes you just need to get rid of it. Places move, you don't use enough, nobody's actually going there. CutePuppyDogs.com, I don't know if that's actually a site, but it's probably not one that people go to every single day.
Site.
It's probably a site.
But and in that time to live, you can skip ahead and flush your DNS, or clear your cache, and try and get it so that you can force it through. Now that may work, but at sometimes time to live is also sitting on somebody else's server that's not controlled by you, right? One of the extra layers leading up. So sometimes you can work around it, sometimes you can't. A big issue in the networking world is misconfiguration.
Misconfiguration, sending you to the wrong port, sending you to the wrong points. That
you got that tech that fat fingered it as they put it in.
Oops.
Yeah. Maybe they added an extra I. You never know.
Put a dot in the wrong place. .con.
.con. The number of times I type my email address. .con.
I'm in .con today, buddy.
It seems really official when you submit that, and you're like, .con, it is legit.
Privacy concerns, that's another big one that people should be looking into. the behaviors of where it's going, what it's doing, how you're getting there.
Yeah, it reveals a lot, whether it's revealing it to those hotels that you stay at as you traverse their network, or even your ISP. It's all data that can be used to track back to who you are and show, this is what you're looking for.
Now, the one good thing about DNS is there are different DNS servers that you can't hit. We could probably go into that. Some of your Cloudflares, your Google's got a hidden DNS, Quad9.
Yeah.
There's a whole bunch of newer ones out there. They're not necessarily newer, but DNS hiding is a big thing to keep your ISP from seeing where you're going, to keep the hotels and stuff, the public Wi-Fi from seeing where you're going. Also kind of leads into the VPN, which we've touched on briefly before. But
yeah, VPN's a great way to begin the protection of your traffic. Now, as we talk future of DNS, of course, DNS started as that unencrypted traffic. We're now seeing DNS move to over HTTPS, going for more of a privacy-first standpoint, less of worrying about, hey, by the way, this is going to take and slow it down. They're now looking at how can I hide some of this traffic, right?
Yep.
Moving from the postcard going across the network to a sealed envelope.
Yes. The blocking the malware is also the big part of that. Blocking it, phishing sites, keeping different people. You want to stop what you don't need from getting on.
Yeah, and with changes in DNS over time, we're going to see the ability to do so, right? You can even block ads today. It's very similar to like Pi-hole by utilizing DNS in the right way, right? They're also looking, of course, at, as we always do in technology, how can we improve speed? Like, yes, DNS today is still milliseconds, but at the same point in time, we're seeing the boom of like the Internet of Things, where you're seeing billions of new devices come on. Well, guess what? Those billions of new devices now also have to query DNS. And so those servers are going to have to deal with more traffic, more queries of that. So we're going to have to look at how can we improve the speed of traffic through that same infrastructure.
I would say that's probably one of the big ways I see us go. Is down people's refrigerators, washers, dryers, microwaves.
Everything talks to the internet.
Cars are talking to the internet, keeping it secure, keeping those DNSs, keeping it from opening up. Being
your microwave to talk to the internet right there.
And who doesn't talk to the microwave all day long, right?
Now, in the DNS field, there's also the potential for blockchain alternatives. Now, none of these are mainstream. None of these are even massively supported throughout the industry. But the idea of like Ethereum name service, or doing the idea of distributing the idea of DNS across a grander scheme than just those 13 servers. Yeah. The other one that we came across is, of course, oblivious DNS. It's the idea of splitting who's requesting from what they're requesting.
Yep. Split it over the HTTPS. So you got your request where you're going, who's requesting it, separate it so you don't. So if you do intercept half a packet, you actually only intercept half a packet.
Nobody knows obviously then, but the person requesting it. The server that's getting the request doesn't know where it's going. The network that's traversing doesn't know who's asking for it or that at the same point in time.
That's a good step into the security side of it.
Yeah, it's a good step as to how DNS will grow over time, and we've seen it, of course, develop from more or less a phone book, and as it moves forward, it's becoming a traffic controller, a security guard, a gatekeeper, more or less a multifaceted approach to what was once a simple problem when you were dealing with a handful of web servers across the U.S.
And I would say with that, kind of going into a closing side of things, with some of the new DNSs, some of your new Cloudflares, some of your new Googles, all the new DNSs that they can get to kind of get you around some of those. There's a lot of new technologies coming out that do help separate, they do help hide, they do help protect. They are killing some of the malware. They're also getting rid of some of the spoofing, but as we develop DNS, there's always one person who can reverse engineer it and figure your way around it. And
it's
a never-ending battle.
And eventually, we'll talk on quantum eventually in the future, but with quantum computing coming, we're talking a whole new level of security controls that are going to have to be developed.
Yeah, quantum's going to bring on a whole bunch of fixes and probably bring on a whole bunch of problems too, but that's a great topic for next time.
All right. But as always, if you guys got comments, like, share, let us know below.
Catch you guys next time.
Thanks for watching.